Hey, welcome back to Beard Squid. In this video, we're going to learn how to use tree diagrams when solving probability questions. Coming up. So in one of my previous videos, you have seen that tree diagrams can be used to illustrate sample space and determine probabilities. Consider the following problem. Stefano is having computer problems. His desktop computer would only boot up 90% of the time, and his laptop will only boot up 70% of the time. Stefano attempts to boot both machines. Part A. Draw a tree diagram to illustrate this situation. And Part B. Use the tree diagram to determine the chance that 1. Both computers will boot up, and 2. Only the desktop computer will boot up. Okay, so for Part A, what we need to do first is we're going to let D represent the desktop computer booting up, and L can represent that the laptop boots up. So we're going to draw our first branch, and our first branch is going to be for the desktop, and our second branch can represent the laptop. So we know from the question that his desktop computer will boot up 90% of the time. So we can represent that the top branch D, which is a desktop computer booting up, is 0.9 or 90%. That leaves the complement, or the fact that the computer doesn't boot up, at 0.1 or 10%. So for the second branch, you know that his laptop would only boot up 70% of the time, which means that the top branch would be 0.7 or 70%. And the complement of L, which is the laptop doesn't boot up, is going to be 0.3 or 30%. And remember that each branch must add up to 1 or 100%. So in each case, the first branch adds up to 1 and the second branch also adds up to 1. So 0.7 plus 0.3 adds up to 1. Okay, so if you complete the final branch, we know that the laptop can either boot up 0.7 or 70%, and then it doesn't boot up, which is 0.3 or 30%. Again, remember each branch adds up to 1 or 100%. So there are 4 total outcomes. The desktop boots up and the laptop boots up, which is D and L. The desktop boots up and the laptop does not boot up, which is D and the complement of L. The desktop doesn't boot up and the laptop does boot up, D dash and L. And finally, neither the desktop nor the laptop boot up, which is D dash and L dash. Okay, so for part B, let's use our tree diagram to determine the chance that both will boot up and only the desktop computer will boot up. So what we're looking for is the probability that the desktop and the laptop will both boot up. Now we know that the desktop to boot up is 0.9 and the laptop to boot up is going to be 0.7. So if you multiply those two numbers, we'll get a probability of 0.63 that both the desktop and the laptop will boot up. Part 2, we're looking for the probability that only the desktop computer will boot up. So if we follow this path highlighted here in purple, we know that we have 0.9 times by 0.3. So that's going to equal to a probability of 0.27 or 27%, the fact that the desktop computer will boot up and the laptop will not. Okay, in our next example, we're going to be looking at if 2 or more branches meet the description of an event, the probability for each branch is found and the results are added. So in this example, we're going to look at bag A, which contains 4 red jelly beans and 1 yellow jelly bean, and bag B, which contains 2 red and 3 yellow jelly beans. A bag is randomly selected by tossing a coin and 1 jelly bean is removed from it. Determine the probability that it is yellow. So we're looking for the probability of getting a yellow jelly bean, but we're relying on a coin toss to select bag A or bag B. Now in that case, if we toss a coin, there's either a 50% chance of getting bag A or a 50% chance of getting bag B, because there's only 2 outcomes from tossing a coin. So either way, bag A or bag B, we can get a red or a yellow jelly bean. So depending on the coin toss, if we do land on bag A, we have 4 out of 5 red jelly beans and only 1 out of 5 yellow jelly beans. If the coin toss lands on bag B, well then we have 2 out of 5 red jelly beans and 3 out of 5 yellow jelly beans. Okay, so what we're looking for is a probability of getting a yellow jelly bean, which is highlighted by this purple path or this blue path. Okay, so we can get bag A and a yellow jelly bean, or we can get bag B and a yellow jelly bean. So let's look at the first probability, which is bag A and a yellow jelly bean. So we know that bag A is a 50% chance because it's a coin toss, And then getting a yellow jelly bean would be 1 out of 5 because there's only 1 out of 5 possible outcomes in that bag. So 1 times 1 and 2 times 5 is 1 over 10. So we have a 1 in 10 chance of getting a yellow jelly bean from bag A. And for the probability of bag B in a yellow jelly bean, well, we have a half times 3 over 5, which is a probability of 3 over 10. Now remember, there are 2 outcomes here. There's this path here, which is highlighted by the purple arrows, and then there's this path here, which is highlighted by the blue arrows. So what we need to do is we need to add those probabilities together. And so if a bag is randomly selected by tossing a coin and 1 jelly bean is removed from it, the probability that it will be yellow would be 4 over 10. See if you could work this out. If a bag was randomly selected by tossing a coin and 1 jelly bean is removed from it, determine the probability that it is red. Once you've worked it out, you can put your answer in the comment section below. As always, thank you for watching. If you found the video helpful, drop me a like, and if you have any questions, put them in the comment section below. And consider subscribing for more math videos. I'll see you in the next one.